In this tutorial, we'll be looking at pH of diluted strong acids. Okay, so let's get started. Now, for diluted strong acids, there is something about them. We would end up having the pH being a little bit above 7, which is not possible. It's supposed to be below 7. So in this tutorial, we'll look at how to go about such question. But then just as a quick reminder, the strong acids usually are HCl, HBr, Hi, HNO3, H2SO4, HClO3, and then HClO4. Okay, so these are the strong acids. Now you realize I repeat this in almost all the tutorials so that you get used to it. It's something you need to have of it. Okay, so let's continue. Now, strong acid, we said they are strong electrolytes. What this simply means is that they will prefer to stay in solution as ions. So if you take a strong acid such as HCl, HCl prefer to be in aqueous solution as H plus and Cl minus. So this is what happens. This is what it means. In the forward reaction, we are going to be having H plus and Cl minus, so much so that we won't have any molecule of HCl about in an aqueous solution. If that is the case, then we say that HCl is a strong electrolyte. It's a strong electrolyte. Now, before we continue, let's remind ourselves that pH is equal to negative log of H3O plus concentration. Okay, now I want us to consider, let's consider 0.1 molar aqueous solution of HCl and H2SO4. 0.1 molar aqueous solution of HCl and H2SO4. Okay, now when we take HCl, because it's a strong acid in water, we are going to be having it dissociate completely to give us H3O plus and then the Cl minus. All this is going to be aqueous. Now, initially, we're going to be having a concentration of HCl to be 0.1, while we have none of this in solution. Now, by the time everything will dissociate, there will be none of HCl left in the solution. And so everything is going to dissociate, giving us equal mole, equal concentration 0.1 of H3O plus and 0.1 of Cl minus. So what will be the pH of this solution? The pH is equal to negative log of H3O plus concentration, which from this equation we see here, H3O plus concentration is equal to 0.1 molar. So when we put that into the equation, negative log of 0.1 molar, what is going to be our answer? We are going to have pH to be equal to, we'll have pH to be equal to 1. Okay, pH is going to be equal to 1. Now that's a very strong acid right there. All right. Now, what this also means is that the pOH is going to be, remember, pOH is equal to 14 minus pH. Okay, so if we want to find pH or pOH from this, then it's going to be 14 minus 1, which means pOH is going to be 13. Is that right? It's going to be 13. Now, what about H2SO4? For H2SO4, it's also a strong acid. That means it will dissociate completely and give us, this time it's going to be 2 moles of H3O plus, and then we'll have the sulfate anion SO4 2 minus. Okay, now for this one too, initially is going to be 0.1, while we have none of this in solution as yet. And in the equilibrium, everything is going to dissociate, and so we have 0.0 of H2SO4 left in solution, while this will have the full concentration, which is going to be 0.1. But if you observe carefully, the more ratio between the H2SO4 and the H3O plus here is 2:1. That means if this is a strong acid and so dissociates completely, then it will produce twice the initial concentration, okay, twice the initial amount. And this we have only 1 mole, and so it's going to be 0.1. So the only difference between H2SO4 and HCl is that in HCl, the H3O plus and HCl are in a mole ratio of 1:1. But when we come here, it is 2:1. And so this is going to be twice 0.1. Okay. Now, what this means is that the H3O plus concentration in this case is equal to 2 times 0.1, okay, which is 0.2. So pH is going to be negative log of H3O plus, which is going to be minus log of 0.2. This will give us 0.2, okay. So what is the value of pH? pH over here is going to be 0.699, okay. That's a very strong acid there. Now, there are some important things that you have to take note of. In this calculation, we do not consider the autoionization of water. This is because we take it as if these acids, any of these acids, are very strong acids. So when it dissociates in water, it dissociates completely. So we're going to have so much H3O plus in concentration that we won't even consider the one that is being produced by self-ionization of water or autoionization of water. If that is the case, then we can say that when we consider the pH of H3O plus concentration around 1 times 10 exponent minus 4, 1 times 10 exponent minus 5, or 1 times 10 exponent minus 6, we would be expecting the pH to be equal to 4, 5, and 6 respectively. So anytime you have a value like this, 1 point something times 10 exponents minus 4, you should always know that the pH is going to be around what the power is, okay? If it is something between this and this, you should be able to predict that it's going to be around 4 and 5, right? Okay, now what if we have the concentration to be smaller than this? If you have the concentration to be smaller than this, so let's consider this. Now, using the same principle, when we say that we have 1 times 10 exponents minus 8 molar HCl, right? What is going to be the pH? What this means is that we'll be expecting the pH to be equal to 8. Now, this is not possible. This is going to be wrong because HCl is a strong acid and there's no way it's going to have a pH above 7, right? It's not going to have a pH above 7. So in this case, what do? In this case, we have to consider the H3O plus that is being produced by water. The H3O plus that is being produced by water. So let's see how we go about it. Now, the HCl plus H2O will give us H3O plus. And then the Cl minus. So if we have times 10 exponents minus 8 here, initially we're going to be having 0, 0. Then in equilibrium, when everything dissociates, we're going to be having times 10, so minus 8 here, 10 exponent minus 8 here. So, well, this is the H3O plus concentration we have from the HCl. Now we'll have to consider that's which water is going to produce from self-ionization. So H2O plus H2O and this is going to give us H3O plus, and then the OH minus. Okay, and if you remember, we say that in a neutral solution, we consider water in its neutral states is going to have a concentration of 1 times 10, 1 times 10 exponents minus 7. Okay, if you remember Kw, 1 times 10 exponent minus 7. So it's going to produce equal concentration of this and this. So this is also going to be 1 times 10 exponent minus 7, right? All right. So this is autoionization of water, and it's produced equal concentrations of H3O plus and OH minus, which is 1 times 10 exponent minus 7 molar. So when we add this, what do we do next? We will now have to combine the two concentration to give us the total concentration of H3O plus. Okay, this is the total concentration of H3O plus, which is going to be the times 10 exponent minus 8 from HCl, and then the times 10 exponent minus 7 from water, right? From water. So what is the pH? The pH, again, we say is negative log of H3O plus concentration. And so we'll be having log of 10 minus 8 plus 10 minus 7. And in this case, what are we going to have? We're going to be having the pH to be equal to 6.959. So when we compare this one, this pH to this pH, we find out that this one makes a lot of sense because HCl is a very strong acid and we should expect the pH to fall below 7. Okay, but then if we go straight ahead and take this concentration and find the negative log of it, we're going to be having the pH to be above 7, which is suggesting that HCl is a base. Okay, so this is how you go about questions of this nature when you have a very low concentration or very diluted strong acid such that you have the pH above 7. Then what you have to do is to consider the autoionization of water. I hope this video helps you in your exam. Thank you.